Hello everybody, this is again Schrodinger's cat and welcome to another screencast. Today we'll be doing Codeforces Round 770, Division 2. Uh, this is the first contest where some some AI accounts will participate. Like, let us see how they perform, but more importantly, let us see how I perform and whether I increase my rating or not. The contest is starting in 16 seconds. 15. Fine. Problem A. Okay. Yes. You are given a string s of numbers of length n and a number k. Let's denote by rev s, the reverse string. You can apply one of the two kinds of operations. Replace s with s plus reverse a or reverse a s plus s. How many different strings can you generate by performing exactly k operations on the original string? If I have some ABC, I can get ABC, CBA, or I can get CBA, ABC in one of the operations. After one operation, once it becomes a palindrome, right? Then I guess the answer is always 1 or 2. Yeah, because if it is already palindrome, then one answer is 1, otherwise answer is 2. But is can k be 0? Okay. I should have a function is palindrome. Yeah, for a string s. Number k. Okay, n and k, fine. If k equal to 0 or is palindrome s, then cout 1. Oh, 2211. Fine. Okay. Wow. Okay. Fine. Let's go on problem B. Your friends Alice and Bob practice fortune telling. Fine. Fortune telling is performed as follows. There is a well-known array A of length n, integers of n non-negative integers. Fine. 0 or positive from 1 to n, indexed from 1 to n. The tally starts with some non-negative number d and performs one of the two operations for each I in increasing order of I. The possible operations are replace their current number d with d plus ai, replace their current number d with d xor ai. Notice that the chosen operation may be different for different i's. At one time Alice started with d equals to x and Bob started with d equals x plus 3. Okay. Each of them performed fortune telling and got a particular number in the end. Notice that the friends chose operations independent from each other. That is, if they could apply different operations for the same I. You learned that either Alice or Bob ended up with the number y in the end, but you don't know whose of the two it was. Given the numbers Alice and Bob started with and y, find out who could get the number y after performing the operations. Fine. It is guaranteed that at least that on the jury tests, exactly one of your friends could have actually gotten that number. It is guaranteed that on the jury tests, exactly one of your friends could have gotten. You cannot make hacks to the problem. Fine. I am not interested in hacking also. Fine. So the thing is that we have to print Alice or Bob. They start with the first line contains three numbers n, x, y, the length of the array. Alice's initial number, Bob's initial number is x plus 3. Oh, is it? Okay, d and d plus 3. One time Alice decided to start with d equals to x and Bob decided to start with d equals to x plus 3. So we have n, x and y. Y is the final number which we have to reach to. Okay. So yeah. 1 7 9, right? And the array is 2. So we have to reach y. Okay, Alice will start with 7, Bob will start with 10. We need to reach to 9, right? How many operations can we do on each I in increasing order? Is it required that we have to choose all the i's? Starts with some non-negative numbers d and performs one of the two operations for each I. Okay, we have to perform for each I and some operation we have to perform. Okay, if it is 2, we can convert this to 7 plus 2, that is 9. Taking XOR, what does taking XOR imply? If we have this, if we take XOR with this, it will become 1 0, and that is 5. And if we take 10 is like this. If we take XOR with this, it will become 8. Fine. For each number I start with some x. Here x plus 3. If I start with an x, I can convert it into x plus ai or x XOR ai. Then I can convert it again into x plus ai plus 1 or x plus ai XOR ai plus 1. Similarly for this, and the tree goes on. We need to find whether we can possibly get y, and similarly for this tree. If anywhere I can get y, okay, it is sure that I will be able to reach I, but who will reach I? That is the problem. That is the question we need to answer to. It is guaranteed that exactly one of the friends could have gotten to the actual number. It is already sure. Fine. If because of this, can we like comment directly which of the friends is actually going to reach? Okay, let's suppose we take this case 4 0 1 1 2 3 4. Here, this one 4. Okay, 4 is the array size. 1 2 3 4, starting with 0, and Alice will start with 0, Bob will start with 3. We need to reach to 1. Okay, is it like we have to reach it till the end or any time in the middle? After performing the y operations, given the number of and y, Find out who could get the number y after performing the operations. Okay. After performing all the operations, right? In the third test, Bob started with 3 and he could get to 3 in this way. 4, then 6, XOR 6 with 3, we get 5. And 5 XOR with 4, we get 1, correct. So we have to perform all the operations. All operations. Those are n. All n operations are compulsorily to be done. Fine. So if I need to do all the operations, I need to figure out some method. Also, y can go till 10 power 15. N is 10 power 5. X is 10 power 9. These are the constraints. Yeah. Now okay. If number is already greater than y, means if the number d is greater than y, we need to decrease it, so only the XOR operation can work. But even if like the number is something like this, d, and we need to reach a y, which is somewhat like this. Yes. XOR can decrease the number if means XOR can either increase the number or decrease the number. We will have to see. And also the fact is that we are starting with 0 and 3. Sorry, we are starting with d and let's suppose x and x plus 3. And only one of them will reach y. Both have to travel some operations and try to reach to y. And one of them will reach y, that is for sure. I can also like try to backtrack. If I have y, if I have some value x, I need to take it XOR with some v to make it y. That means v itself is y XOR x. So I try to perform the operations in reverse order on y and try to find if I can reach to a or b. And the plus operation becomes minus. Either I will subtract something from y, or I will take the XOR itself. How many submissions on B? 573. Okay. Fine. Okay. Okay, x and x plus 3. If x is something like this, maybe this x plus 3 will become 3 is just this much. We will get this. Okay, so where was I? Yeah. The difference is only in the starting 4 bits of the two numbers. The numbers themselves are around 10 power 9, right? Yeah. That means 31 digits I will have. Only the first 4 digits will have some differences in the bits. Rest all will be same. If I need to reach, I don't think dynamic programming will be used here, which I have 10 power 5 AIs, right? This is the size of A. At each place I can do 2 things. So it will become 2 10 power 5. 2 to the power 10 power 5. That is very huge number. And also the possibilities are enormous, because y can be till 10 power 15, right? So even memoization will not work. So DP is not working. If I have Yeah, I just need to tell who can get to that number y. Can I guess by seeing some property whether some number can reach x or y? The thing is that I can pre-compute and keep the XORs of all the values, which is okay, and I can take the XOR with some value, with the value itself. I will take, let's let us consider x as the XOR of all the values. Fine. So D XOR x is when I choose all XORs. Fine. But if I do, let's consider this. Value tx, total XORs. If I take total XOR mod a1 plus a1, this is when I did a1, when I got a1 as, at the first index I did summation and all rest as XORs. But only for a single value, I think. But now if I also consider that at third index we had to do, we did not have to do XOR. I don't think this will work, because, or will it? Because the value has been changed. Okay, so some people have done like very fast, 5 minutes, 6 minutes. So there is something very basic in B which I feel, because of the fact, like, two things I doubt on. First of all, numbers are separated by 3, and secondly, one of them, exactly one, will reach exactly Alice or Bob, and not, okay, yeah, exactly Alice or Bob. Numbers like 2, 3 and 5. I can go to 6 or 6. Let's just think for 4 at the moment. For 6, one of the possibilities is, okay, I have 5 also. Yeah. One of the possibilities is that I just keep on adding 6, 9 and 14. Other thing is, like, maybe I will do XOR 100 XOR with 106 itself. Fine. So it will give 6 only. Otherwise 6 can give me XOR with 3, which can give me 5. Fine. And in 5 I can add 5, or I can do XOR with 5, which will give me 0. And with 7, if I do, this can go 9, then 12, and then 17. But 7 XOR 2 is 5. 5 can give me 8 and 13. 12. Okay, 9 can also, I could add 5, or I could do XOR with 3. This will give me 10. Fine, 10 can be XORed with 5 to make 15, or added 5 to be 15. Fine. For 8, either I could have added, or I could have done XOR. So this could have given me 13 itself. 8. Yeah. Given me 13, fine. 5, I could have XORed with 3 to give 6. Then 6, I can add, or I can do XOR with 5 to give me 3. So I get 0, 10, 14, or I get this 15, 17, 13, 11, 3. Is it like odd or even? Because these are all evens, these are all odds. Okay, because the thing is like, no, because let's say, one more case. I had 4 and 7. 4 is always even, 7 is always odd. Fine. So let's say I have my array as 2, 3. This time 2 plus 3, 5. At this time 2 plus 3 plus 5 was itself even. Now 2 plus 3 plus 5 is 2 plus 3 is 5, so it is odd. So I can go 6, 9, or I can do 6 with 3 to get 5. I can do XOR with 2 to get 6. And then again 6 will give 9 or 5. With 7 though, I will have 9. 9 can get to 12, or I can do 9 XOR with 3, which will give me 12. Will it give me 12? 9 plus 3. 9 XOR. This is 12, right? This is 1, this is 0. 5. Acha, this is 10, sorry. Yeah, this is 10. Otherwise I could have like added, I could have XORed with 2 to make it 5. And 5 is basically, what is 5? Okay, 5. I could add 3 with 5 to get it 8, or I could do 5 XOR 3 to make it 4. So all these are still even, these are odd. Okay, so if I start with an even number and I have the sum of AIs, which is basically summation AI. Let's write it here. Basically, if I have X as even and summation of AI as even, both as even, that means here even and even, even. So Alice will reach even number. So Alice will reach even only, and Bob will reach odd. Fine. If both are odd, that means the sum was also odd. If both were odd, then Alice will reach odd and Bob will reach odd. This is not a solid, whatever I'm saying is not some solid conclude. It is just some observational, on observational basis I'm saying. Both are odd. Else what will happen is that if x and summation, if x is even but sum is odd, if x is even, that means let's suppose x, this was x, so I could have got 10, so this would have become Alice and Bob, right? So if x is even, then Alice will reach even itself and Bob will reach odd. And if it is the other round way, if x is odd and summation is even, if x is odd, okay, let's suppose this is x and summation is even, so Alice will reach odd and Bob will reach even. Fine. So the thing what comes out to be is that if x is even, okay, if x is even, can be hard coded write the if else statements, but I'm thinking to write it more efficiently. So the thing is that if x is even, both are even. First let's find both. Let us find what is the input format, 3 numbers n x y and then the array. Okay, I also have some. Fine. Now what I'll do is like okay, if sum is even and y is even and x is even, sorry, or maybe like this we can do. Yes, if sum is even and x is even, sum is even if x is even and if y is also even, Alice, else Bob. Fine. Okay, if sum is even, if sum is even and x is odd, if x is odd, then if y is odd, then Alice, otherwise Bob. Alice, fine. Now the other way around, we can just write, okay, we can write else. Okay, if the sum is odd, this time sum is odd, these two cases, if x is even, okay, if x is even, okay, sum is odd, x is even, so Alice will reach even, that is correct. Else what will happen, if sum is odd, x is odd, so Bob will reach even. Oh wait, if it will be like the reverse order, right? If y is even, so Bob will reach it, otherwise Alice will reach it. Fine. Yeah, Alice, Alice, Bob, Alice. That is correct. But my printing is wrong. I'm not printing it correctly. I have to print. Uh, Alice. And for Bob also. Bob. Fine. I'm printing. Alice, Alice, Bob. Bob, Alice. Fine. If this runs, like, it is very surprising for me because it is just experimental. I have not proved it. I don't have a proof yet. Wrong answer on pretest 2. I knew that. But I guess it is somewhat on these lines only. Let's suppose I have only one value. I have 6 and 9 and I have a as 3. Either this will reach to 9 or this will reach to 6 or 5, or this will reach to 12 or 9 or 3, which will become 10. Fine. Okay, so the thing is, like, if a number is even, after performing the operation it will become odd. Yes, the thing is that after performing one operation the number becomes odd, but then if I again perform, okay, it doesn't become odd, it changes itself according to the number itself. If I had 6 and 9, sorry, 6 and 9 and the number was 4, this would have become 10, or maybe maybe 4, yeah, whatever. So we can just iterate and check, I think. We don't require sum, we just require all the values. Int, let's call this e. Okay, so initially it is 0, that means it is even, or maybe it is like x mod 2. Initially it is odd, it is x, that means what Alice has containing. If okay, now we do e plus equals to is equal to e plus ai mod 2 if e is equal to 0. Alice, Bob. Is this what we want? Something is wrong still. The thing is that Alice has 7 initially. We are checking for Alice. Fine. Let's suppose Alice has x in the starting, but then okay, let's suppose we have like some 7 in the starting. Alice has x in the starting, then she will convert it into the parity of 7 plus a1, then 7 plus a1 plus a2. That means at the last the parity will become equal to 7 plus summation. Fine. So is it like we can use the summation? Okay. If x plus the summation itself, summation, that means if x plus summation has the same parity as y, Bob. Alice, Bob, Alice. I guess this is correct because, yeah, if both are okay, let's try to submit first. Yes, that is correct. Okay, because of that wrong answer my points have decreased a bit. However, like, okay, what is the score without the unofficial? Fine, plus 14 expected. Let's go and try to try problem C. How many summations on C? 1767 already. C is somewhat similar. Okay, you work for a well-known department store that uses leading technologies and employs mechanistic work, that is robots. Department you work in sells n times k items. The first item costs $1, second item costs $2, and so on. Sells n into k items. The items are situated on shelves. The items form a rectangular grid, n shelves in total, and exactly k items in each shell. We denote Aij as the price of the jth item on the ith shelf. Okay, ith shelf and k. Okay. Occasionally, robots get curious and ponder on the following question: what is the mean price? Arithmetic average of items. Okay, for some, okay, unfortunately, the old robots can only work with whole numbers. If the mean price turns out to be an integer, they break down. You care about robots' welfare. You want to arrange the items in such a way that the robots cannot theoretically break. Formally, you want to choose such two-dimensional arrays that every number from 1 occurs at least once. We just need to rearrange all the numbers from 1 to n into k, and for each ILR, the mean price of the shelf is an integer. Fine. This problem is like loosely related to a problem I did on CodeChef some days ago. Okay. See, so basically we have some matrix like this, and we have numbers like this. And so on, right? Or maybe like we can keep it this much for now. So the thing is, like, we have to rearrange these numbers in such a way that even if I take a small subsquare, this, the average of the subsquare, right? Not subsquare, subrectangle. If I take a subrectangle, that subrectangle does not have a mean, not an integer. Fine. So every subsquare, if I have like this. Any subsquare if I have I. How do we need to print out? Think yes or no. If such an arrangement exists, print yes. After that, print an example of n lines and k numbers each. One line per shelf. Okay, 1 1 2 2 3 1 3 3. Yes, yes, no, yes. 3 3 is no. 1 2 3. Okay, 1 plus 2. Okay. Yes. For a smaller subcase, when, like, let's suppose n equals to 1, we have and we want every sub array, every sub array to be divisible by its length. Fine. That means if I take here 4 plus 5 9, then 6 15 and 7 23, this is not divisible by 3. So it is always the thing that if we reverse the numbers pairwise, that is 2 1 4 3 6 5, now it will be always divisible. Okay, it will always be not divisible, sorry, we have to make them divisible. Okay, so in one line, if they are in a single line, I have to make them divisible. 1 2 3 4. Okay, 1 2 3 4 is always divisible, but the thing is that if I start from here, the numbers will be of the form x plus 1, x plus 2, x plus 3 up till x plus k. So it will become x, and summations are like summation of k is k into k plus 1 by 2, k times k plus 1 by 2. Fine. And that is also divisible by k. So it is basically what we get is x by k plus, or maybe we get x plus, like basically this number is always divisible by k if k is odd. Fine. No, not really. If I have 4 5 by 2 into 4, or I have 5 into 6 by 2 times 5, yes, this will be divisible, but this won't be divisible because, yeah, k should be odd. Sorry, k plus 1 should be odd and k should be even. We need k to be even. Okay, we need k to be even. So if k is odd, the answer is just no. But if k is 1, if I have this, k should be even. K should be even. This length is k plus 1. If I have 3 comma 1, my value is 1 2 3. So 1 2 3 is correct. What is the mean price of items? IL plus 1 Oh my god, I have misunderstood the problem. It is not a sub box, sub square. It is like a sub. In one shelf only it is asking us to do. That means AL say AL R, okay. Okay, you want to arrange the items in such a way that the robots cannot theoretically break. Formally, you want to choose such a two-dimensional array A that for every number 1 to n times k, okay, that is correct. For every I from L to R, for each I L comma R, okay, for each of the substring, sorry, sub array of at each level, it should be divisible by the length of itself. Fine. So if I have 1 2 3 like that, I can have 2 1 3? Yes, because no. If I have 2 comma 2, so I have it in this way. I have 1 2 3 4. Okay, I can convert it into 1 3 and 2 4 because of the fact that every, so the thing is that every AI and AI plus 1, or maybe in this perspective we can call it as A I comma j and AI comma j plus 1, yeah, should be even in sum. Then every, basically AI comma j plus k, where k starts from 0 to -1, so k will start from 1 to some value t, should be okay. So the summation is, if it is single value it is okay. If there are two values, they should be divisible by 2. If there are three values, they should be divisible by 3. They should be divisible by t. Is this the only thing? We just need to find a pattern of such kind. So if I have 1 2 3 4, right, only single, these 3 are divisible, these 4 are not divisible. Same for only 1 and 2, but when I got 1 and 3, can I like always do it for, if I had 5 6 7 8, can I make it like this, 1 5 and 2 6, and similarly for this one, 3 7 and 4 8. Will this work for the 3 3 bunch? 10 and 6. 10 and 6 is 16, and 3 plus 6 is 9. Okay, 9 is divisible by 3. Okay, and here also, if we go for, it is 12, it is 20. Yes, but if I have n as odd, maybe like this, 1 2 3 4 5 6 and 7 8, like that, then also we could have done the same thing, I guess. We can just exchange the diagonals. 4 2 3 1 Yeah, that is basically correct because, yeah, if I have odd comma odd, even for like 1 comma 3, 1 2 3 was correct. If I have 2 comma 3, that is 1 2 3 4, 3 comma 2, that means 1 2 3 4 and 5 6. 1 2 3 4 5 6. How many odds and evens do I have? I can have like this 1 and 3 and 2 and 4, but 5 and 6 will remain as it is, right? I want odd with odd. If I have like an array of 3, let's suppose 3 cross 3. So a 3 cross 3 array is basically having odd even odd even odd even odd even odd. There is not an equal distribution of odd evens and odds, right? Which was the case here also, but here the answer was 1. But here I can have 1 2 3 4 5 6 7 8 9. For these 3 it is working, for these 3 it is working. Does it work? Yeah, because if I have 3 consecutive values of x, x plus 1 and x plus 2, they are always done, but consecutives might not work. Okay, so the thing is that I cannot have odd with even in one I cannot have odd adjacent with an even. In one row either I can have odds or I can have evens. Fine, I can't have both. Fine. So that is basically the thing. If it is possible, if the distribution is possible, because here it was possible, odd even odd. Here it is not possible because I have 4 odds and 5 evens. I can make odd odd odd, even even even, but I have to have odd odd even. This will break here. Fine. But if I have, so the thing is, if n into k is even, if n into k is even, so I will have evens are equals to odds. Sorry. The count of evens are equal to count of odds. That means if I have 2 times 3, and I have 3 times 2. Fine. Yeah, I will have evens equals to odds. So in one array I can place all the evens, in other array I can place all the odds. What about such case? What about such case? If I have 2 comma 3, sorry, 3 comma 2. 3 comma 2 is also wrong because only 3 comma 1 is possible, I guess. If n is odd, the answer is no. When k is greater than 1, only for 3 comma 1. And if I have like 5 comma 1, yeah, it will always be possible. If I have 5 comma 2, 3 4 5 6 7 8 9 10. So even odd, I have equal distribution of even odds here also. Okay, even odd, I can make but 5 5, right? But 5 5, I can make 1 3 2 4, I can make 6 8, then 7 5, but 9 10, they will get matched here. So the thing is that I should have count of these also even. That means I should have okay, so the thing is that if n is odd, I want all the odds and evens here. How many submissions on C? Oh, 3000, 3700. More submissions on C than B. Wow, that is interesting. And no submissions on D at all. Okay. That is fine. So the if n is odd, and k is greater than 1, because yeah, now n is, suppose n is even. If n is even, so n I will have, let's suppose 4. Let's suppose 4 cross 3, I have to 12. Choose orange. This one. Yeah, I have 1 2 3 4 5 6 7 8 9 and 10 11 12. So I can form like this, 1 5 3 and 4 2 6. Just exchange these, 7 11 9 and 10 8 12. Fine, this is correct because yeah, this will be correct. If I have 1 3 5 2 4 6 7 9 11 and 8 10 12, that is correct. And if I have 4 4 1 3 5 1 2 3 4 5 6 7 8 11 12 13 14 15 16 2 4 6 10 12, yeah, that is divisible by 4 3 2, everything is done. Here also x plus 2 x plus 4 6, yeah, that is correct. So placing all the evens, consecutive evens, consecutive odds, fine. Yeah, so I think this is the answer. If n is even, n is odd, we'll have separate cases. Input value, input method is just n and m, n and k basically. Okay, I've taken input n and k, okay. Now yeah, if n is even, 0. Fine. If n is 0, we'll do loop from, we can do a for loop. I is less than n. Yes. A of I, we'll do loop I comma k. AI is equal to v and a of I plus 1 comma j. Okay, j. A of I comma j is just v, and a of I plus 1, j is also v plus plus. Fine. Let's try to print this if it is correct. Why? Oh, okay, answer. Let's make this a. 1 3 5 7 2 4 6 8 9 16. Fine, that is correct. And if it is 4 comma 3, 1 3 5 2 4 6, that is correct. If n is odd, if n mod 2 equal to, if n mod 2, so what we'll do is that if k is equal to 1, and then we'll do else cout no. Okay, yes and no also is there, and we just return. And cout yes, and here we'll do cout yes. Yes, yes, no, yes. 1 2 3 1 3 2 4, that is correct. Let us add some more cases. 5 comma, okay, I guess all will work now. Fine, C is also done. I would like to try D, but seeing the very low summations on D, I guess I will cover the solutions of ABC and just end the stream here, because I don't want to make it more very lengthy. If I'll be able to do D, I think I'll put the solutions of a separate solution video for D. But let me cover the solutions of ABC here, because extending the stream more 1 hour 20 minutes is of no point, I guess, because there is a low chance I'll do D. So yeah, let us come on the solutions part. Okay, we'll see solutions. Okay, solutions, yeah. So A. So problem A, I think you might have read. A was very easy problem. The thing is that they have told us to reverse the string and append it on either on the on the end or on the start. Fine. That means if I have a string, if I have some string like a b c d, I can, in one operation I can convert it into a b c d d c b a, or I can convert it into d c b a b c d. Fine. So one of the thing which you might observe from here is that once a string is a palindrome, right? Once a string is a palindrome, basically what is asked exactly after, we need to tell how many different strings can we get exactly after k operations, right? Exactly after k operations. So the thing is that if a string is a palindrome, let's suppose ABA, performing the first operation or the second operation, ABA, or you do ABA, you'll get the same string. And even if you perform again and again, the length will increase, but the strings will be always same. So at last you will get only one string. Fine. If you start with a palindrome, and if you don't start with a palindrome, such as this, in one operation you will end up getting a palindrome, right? These two are palindromes because s dash or s dash s is essentially some kind of palindrome where s dash is mirror image of s. Fine. So if it was not a palindrome, then in one operation I will get two different kinds of strings which are not equal to each other, and after it they will then become palindromes. They will stay palindromes and they will give equal answers in themselves. This will always give some equal answers in its tree. This will give some equal answers. So I will get two answers. Also the thing is that if I have a string which is not a palindrome, but k is already 0, I can't do any operation. So answer is 1. So so basically the code will be basically this one. I will check if k is 0 or the string is a palindrome, print 1, else print 2. How will I check if it is a palindrome? For that I have written a function here already above, in my set of functions, is palindrome for a string s. Fine. If you can see here, if si is not equal to si, for each index I will check its corresponding mapped index, which is n minus 1 minus I. If you think a bit, you will understand why I is always connected with n minus 1 minus I. So for each I, si should be equal to n minus 1 minus I. If it is not, then it is not a palindrome, right? So basically I'll break it, I'll make b equal to 0 and break. So and I'll return b. Fine. That was A. For problem B was a very good problem, I think. Problem B. In problem B, we have been told that either Alice or Bob, one of them will surely have an answer. Fine. Either Alice will have an answer or Bob will have an answer. Fine. So this is one point to be noted. Other point is like Alice will start, let's say, with a number x. So Bob will start with a number x plus 3 at the starting. So if this is here, we can see that the parities are always opposite. If x is even, x plus 3 is odd. If x is odd, x plus 3 is even. That means x mod 2 is not equal to x plus 3 mod 2. Why? Because this is x mod 2, and if we open this will become x mod 2 plus 3 mod 2, which is 1. So some value cannot be equal to its value plus 1. So it is not equal. So this is the second thing which we need to keep in mind. That means both of them have different parity. Now what the thing is that the key observation here to be made is that if we have a number even, or let's suppose we have any number x, if I do x plus ai, or I do x XOR AI. So x plus AI has the same parity as x or AI. Fine. Either both are even or both are odd. Fine. So basically, the thing is that if I start with any number x, I apply a couple of operations. I apply the first operation with 1. Either I do XOR or I do plus addition. Doesn't matter. I will have uh, the parity of x plus AI, A1. Then if I do A2, then I will have the parity of x plus A1 plus A2. Okay. Parity of this. At the last, we will have x plus summation of AI. Parity. Like if x plus summation of AI is odd, the final answer starting with x will always be odd. Fine. And therefore, if I start with x plus 3, the whole operation, it will become x plus 3 means its parity and plus summation of AI, its parity. That means if I start with x and if I do some operations and I get all the numbers as odd, so starting with x plus 3, doing all the operations, I will get all the numbers as even. Fine. And now if y is odd, then Alice will reach to the answer. If x is even, then Bob will reach to the answer. Fine. That means I need to check if x plus summation of AI has the parity which is equal to y's parity. Fine. If that is so, then Alice will always reach the answer. Else, Bob will reach the answer. Fine. So this was the solution of B. This was a very good problem, I think, because there were multiple directions to think upon. But basically, this was the logic of the problem. Fine. Coming to problem C. Coming to C. Okay, let's open problem C. Problem C. So yeah, in this problem, what we need to do is we have the numbers 1, 2, 3, 4, like this. Then k plus 1, k plus 2, like that. Then 2k plus 1, 2k plus 2, like that. I have a matrix already. Fine. Like that. I have a matrix. I need to rearrange these numbers in themselves so that for any range AI plus L, AI plus L plus 1 up till AI plus L plus R. Okay. The summation of AI from I equal to I plus the summation of the whole AI should be divisible by its length. Let's suppose I have L length, L numbers in this, should be 0. Fine. So the thing is that this should be true. This should be true for L equal to 2 also, and for greater L's. So if it is true for every I and L equals to 2, that means if I have some number AI and some number AI plus 1, their summation should be divisible by 2. Fine. Every two consecutive numbers should be divisible by 2. That means AI mod 2 should be equal to AI plus 1 mod 2. That means I can have odd or I can have even. Fine. These are the two possibilities I can have. I cannot have odd and even in same row. That means if I cannot have same row in same row, so that means if in row 1 I start with an odd, So every 2 should be odd. That means the other one should also be odd. That means the other one should also be odd. That means the other one should also be odd. So that means the whole array should be of odds only. Fine. Then row 2. If in row 2 I start with even, then other row should also be even. Then all like that even. Fine. If any row starts with an even, so that means either the whole row can have odds or the whole row can have evens. Fine. For this to happen, there are multiple cases, because I have all the numbers from 1 to n times k. I have all the numbers, right? So if n into k is even, if n into k is even, that means I have count of odds equal to count of evens. Fine. Yes. Else I have the difference of count of odds and the difference of minus the difference of count of evens is equal to 1. That means someone is one more than the other. Fine. Yes, someone is one more than the other. You can draw and check this, or like also prove this mathematically. I won't do this. Fine. And the thing is that if we have some n rows and k elements in each row, let's suppose I have 5 rows, out of which 3 should be evens and 2 should be full of odds. Fine. Or vice versa, 3 odds and 2 evens. So without the loss of generality, without the loss of generality, let us consider this to be the case where if I have 5 rows, I want 3 rows to have evens and 2 rows to be odds, and vice versa will also be hold. If I want 3 evens, so I want the count of evens. How many evens do I need total? I need total total evens to be 3 into k and total odds to be 2 into k. Fine. So what is the difference between the total evens and odds here? Evens minus hash of odds comes out to be k. But earlier we have seen that this can only be 1. Fine. So this will prove that if n is odd, so k can only be 1. If k can only be 1, if n is odd, this was odd. If n is odd, then k can only be 1. If n is odd, then k can only be 1. And the pattern will be just print them normally. 1, 2, 3, 4, 5 like that. Fine. How many ever. This will be odd, this will be even, this will be odd, this will be even. This whole row has only odds, this whole row has only evens, because there is only one value. Fine. Now for n equals to even. Before this, you can also try to make this for 5, 2. You won't be able to do all odds, all evens. Basically this pattern you won't be able to make if n is odd and k is not equal to 1. Fine. So for n equals to odd and k equals to 1, it is the answer. This is the answer. If k is greater than 1, then answer is no. What if n is even? If n is even, we have count of odds equal to count of evens, right? And I can evenly distribute into n by 2 and n by 2. N rows into n by 2 and n by 2 rows for evens and n by 2 rows for odds. Fine. So I can, okay, and that will be equal to n into k by 2. Fine. Half of them are evens and half of them are odds. That means if I have let's suppose I have 6 rows total. 1 2 3 4 5 6. So this row can be given to evens, this row can be given to odds, this row can be given to evens, this row can be given to odds, this row can be given to evens, this row can be given to odds. Fine. And I will have the values to start with. I will always have equal sufficient number of values to fill these rows. Fine. Now how to fill? This is the problem. Okay, how to fill? Let's suppose k is equal to, here k doesn't matter, here it doesn't matter what is k. Let's suppose k is 3. So I have values from 1 2 up till 18. I have all the values. So you can see that if I place the values consecutively, like I have to place all the evens, right? So 2 4 6 8 10 12 14 16 18 and all the odds 1 3 5 7 9 11 13 15 17. If you place it in this order, or like you can also start with this, with this, like that, starting with above odds and evens. Fine. Why this works? Because if you have, you can see that all the values are in an arithmetic progression and they differ by 2. Fine. They differ by 2 from the other value, from the next value. So let's suppose you have k values. You start with some value x, you have x plus 2, you have x plus 4, and so on. You have x plus if you have k values, right? So the last value will become 2 into k minus 1, right? Yeah. So the summation of this will become k into x plus 2 plus 4 plus 6 plus 2k minus 2. Fine, this will become kx minus 2, and this summation will become 2 times k into k plus 1 by 2. Fine, that is kx is it k plus 1? Wait, the thing is that if you have all the values in an arithmetic progression with the common difference is 2, so choosing any length of values in middle, you will always make it divisible. Fine. For this length of k, let's suppose you have this array itself, this series itself. If you have the series itself, summation will become basically the summation of the arithmetic progression comes out to be, let me write it directly, I think I've done something wrong. Yeah, the summation will come out to be this thing. Fine, this is the summation. Yes, and if we try to divide this, this will become k. Yeah, I think I'm messing up something, but basically what will happen is that okay, you will have summation as k into x plus 0 plus 2 plus 4 plus 6. If you have k values, you will have k minus 1 times 2, and this summation is always divisible by k. And why is it so? You can try, I actually tried this for all. You can generate the formula and see. If you have k as 1, you will always have 0. If you have k as 2, you will have 0 plus 2, which is divisible by 2. If you have 3, then this will be 6. If you have 4, this will be 12. If you have 5, this will become 20. All are divisible by their own length. Fine. So the thing is that you can always do this. In each array, you just place consecutive. In each row, you just place some value, start with value x, then x plus 2, then x plus 4, and so on. And it will be correct. Fine. So any of these two methods might work. Fine. Just tell me in the comment section if you prove this correctly, if you did this mathematically and proved this. This is a very easy thing, but I don't know why I'm not getting it now, but nevertheless I don't want to increase the length of the video, so I think I will finish the video here. C was a very good problem. I covered it in depth so because of that it might have gone long, the length of the video, but anyways I hope you enjoyed the solutions, and see you in the next stream. Bye bye.